Hey Geometry, so today we're going to take a look at a couple of more shortcuts for proving that triangles are congruent. We're going to have ASA and AAS, and you can probably guess at what each of those is. So in the last lesson, we learned that two triangles were congruent if we had either side, 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 or side, angle, side. And then actually we even threw in a third one there if we had hypotenuse, leg. So we had all three of those. And you notice that each of those involves, so this involves three sides, this one involves two sides and an angle, this one involves technically two sides and an angle, the hypotenuse. But then today we're going to focus on sums that are kind of more angle intensive, so we can go if we have angle, angle, side, or if we have angle, side, angle, we can prove that they are congruent. So angle, side, angle, I guess we'll start with that one. If two angles and the included side of one of the triangle are congruent to the two angles and the included side of another triangle, then the triangles are congruent. So if we have this side here is congruent to that side, and then the angles on either side are congruent, if we know one side is a fixed length and then the other, the angles there, they have to meet at a specific point. There's only one triangle that can create, and so in that case we end up with congruent triangles. If we have angle, angle, side, so if I have an angle, and a side, or if you reverse this, side, angle, angle, that, you know, we tend to write it this way, but you could write it the other way as well, side, angle, angle. We also end up with exactly one triangle. So if I have this side's congruent to that side, so I've got a side there, an angle for a line, and then I have a final angle, and it has to meet at this other length here, it turns out that we know that those triangles are congruent in this way. So we know that that angle, you know, coming off of this triangle is going to set this in a certain path. This angle can be fixed somewhere on that, and it's going to have to be in the exact right spot to meet at that other side. So because of the way that things are fixed there, we know that those can be true. I'm going to go ahead and take a quick pause and say, you know, what we don't do. Like, all right, so we had side, 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 sine, angle, side. What we don't do is side, side, angle, or I'm going to write it, but we don't do that. When that's a bad word, we don't do this. So no. If you think about why that one doesn't work, if I have a side and then another side and an I guess a side, another side and an angle, there's a couple of ways that one can work out. So if I have like, say I have, you know, this here, and I have an angle, and then I have another side. Let's say I have, I don't know, let me go with something like this. I have this fixed angle. So I know this is one of my angles, and I know this is one of my sides, but then I have this other side, and so I know this angle is going somewhere on this ray, right? So this is, you know, some ray. Well, if this other side could actually be in a couple of different places, I don't know, if I have the second congruent side, there's actually a couple of different triangles that we could make if I had an angle, a side, and a side. In certain situations, we can make a couple of different angles, and so that's why that one doesn't work out. Basically, every other combination is good. If I have, and actually we'll get to the last one we'll get to later on, but if I have this situation, then, you know, that's, yeah, there can be a couple of different triangles, so that doesn't work out. But if we have three sides or two sides with the angle in between, if it happens to be a hypotenuse, we know it's a right angle, then we're good, because that actually technically is like an angle, a side, and a side, but it's not ASS, it's not bad there. Then we're good. If we have a couple of angles in one side or a side, you know, and this could also be written S, you know, SAA if you wanted to, or angles with a side in between them, we're good, but not this. The last thing you can think about is, what if we have all three angles are the same? Well, if that's the case, you're going to have what we call similar triangles, and this is a whole nother unit, where they're going to have the kind of the same, like it could be different sizes, right? But there's going to be something constant about it, and that we'll see the sides are in proportion with each other. So, you know, none of that, and then yeah, like angle, angle, angle is, we're going to say, is not good for now. That's a rule we'll use actually for if triangles have a proportional similar relationship. All right, so continuing on this page, determine which postulate, if any, can be used to prove that these triangles are congruent. So here we've got the hypotenuse here, and this is supposed to be a line, a leg. Sorry, that didn't show up really well. So we can show that through hypotenuse leg. Again, we're not really using angle side. That's not allowed. We're using hypotenuse leg in that case. Here we've got an angle, and then we've got side, and then we can show that these angles are congruent to each other through vertical angles. So we've got angle, angle, side. Then we can show those are congruent. And then here, we know that if these lines are parallel, we could say that like this angle here is congruent to that angle. And so we have a couple of angles, and then we can show that this side is congruent to itself. So angle, angle, side for that one as well. There might be other ones of those. So this part 2 says find a counterexample to show that angle, angle, angle cannot be used to prove triangle congruence. So if we just think of like, I don't know, like an equilateral triangle, if I go with a 60, 60, 60, well, there's one. Is that necessarily congruent to this triangle that's 60, 60, 60? So angle, angle, angle. The angles are congruent, but they're totally different size. And so that's one thing we can't use angle, angle, angle for. All right, so then here I can use angle, side, angle, or angle, 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 side to prove that triangles are congruent. So we've got our given QS bisects PQR, so QS bisects PQR, so we'll pretty quickly be able to say that those two angles are congruent. And then we have angle PSQ, so PSQ, this angle here is congruent to RSQ, that angle there. So we can get those couple of angles, and then we'll finish up our proof. So let me get this one started. All right, so there we go, got that one started. So first, we can say that angle PQS is congruent to angle RQS from the definition of angle bisector. So we got those angles are congruent. We already knew the other ones were, and then we could say SQ is congruent to itself. Segment SQ is congruent to segment SQ from the reflexive property. And then once we got that, we got angle, side, angle. So we can say that triangle PQS, trying to squeeze this in, is congruent to triangle RQS. And this is from angle, side, angle. Angle, side, angle. And the order, of course, that matters. Angle with a side in between of two angles. Couple more to practice on the back. So in this one, we're told point L is the midpoint of WE and WR is parallel to ED. So L is the midpoint of WE. So we're going to be able to show that those sides are congruent. And then we're told WR is parallel to ED. So parallel there. Let's set this up and get going on it. All right, so we got our givens down. So L was that midpoint. I marked it as congruent, but we got to make sure we make this statement. Segment WL is congruent to segment EL. And so we can say that because of the definition of midpoint. All right, and then we've got these parallel lines here. So there's a couple of ways we could go about this. We could actually either go this, kind of use both alternate interiors here from a couple of transversals. We could also use our vertical angles here. And so you can actually do this one either with angle, side, angle, or angle, angle, side. So I'm going to do the angle, side, angle just because it's maybe a little bit fancier to use a couple of different things. So I'm going to show that angle E is congruent to angle W. So angle E is congruent to angle W, and that's from alternate interior angles. I've got my two parallel lines. This is my transversal. These would be alternate interior angles. So that's alternate interior. angles. So like I said, you could do another alternate interior angles for those and then do an angle side. But instead of doing that, I'm going to go here. I'm going to show that these are vertical. So we could also say that angle ELD is congruent to angle WLR, and that is vertical angles. So another potential justification you can use. Vertical angles. And so then at this point I have angle side angles. So we can say that triangle WLR is congruent to triangle EDL, and that is from angle side angle. But like I said, you could have done angle side if you wanted to on that one. All right, last one here. Suppose that the redwood supports in a structure TU and TV. So TU and TV measure 3 feet. So those are both 3. And TY is 1.6 feet. And the measure of angle U and V are 31. So this measure is 31, and that measure is 31 as well. Determine whether TYU and T is congruent to TYV. So is this angle congruent to that angle? Explain your answer. So what we have here is we've got an angle, a side, and a side, an angle, a side, and a side. So we can't actually know for sure that these angles are congruent. If they had told us something else was going on here, if they'd given us these sides were congruent, but it's possible that this, there'd be a couple of different angles here. This 1.6, if this, again, if this isn't drawn right, this, this makes it appear that they're congruent, but we can't know it based on what's been given. This 1.6 could, slant one way or the other way and still potentially make a couple of different triangles. So they can't be proven. Congruent because we have angle side. All right, and we're not allowed to do that. So we can't show that they're congruent in that order, or side angle is the same. I stick with that because people tend to remember the bad word better. Yep, can't show that those angles are necessarily congruent for that one.